Right, so this is a kind of a work through of the chemistry foundation year 11 SAMs, okay, so the sample assessment material. So the first question asked you to give letters of two hydrocarbons that are alkenes, okay, so alkenes is something with a double bond, okay, give a reason for your choice. So it would have been A and D because they both contain double bonds. The next one then says, give the letter of the hydrocarbon with the molecular formula C3H6. Okay, so you're looking for something that had 3 carbons, 1, 2, 3. That one's also got 3 carbons, but 6 hydrogens, okay? Give the name of hydrocarbon B. Okay, hydrocarbon B had 4. So remember you have to go meth, eth, prop, bute, pent, okay, so it would have been 4 carbons if you wanted 1 carbon, 2 carbons, 3 carbons, okay. Bute, no double bond, so it ends in ANE. If it has a double bond, it ends in ENE, okay. An alkene contains 2 carbons and 6 hydrogens. Draw its structural formula. Remember, carbon has 4 bonds, so you can work out then where you're going to have a double bond or not based on how many bonds are coming off the carbons with the 6 hydrogens. Then this is looking at monomers and polymers in terms of forming plastics. Remember, polymers are just the same thing but with the double bond removed, so they can form long chains, okay, so double bond removed, and you kind of stretch it out and add, like, stretch there and put it in a bracket with a little N on it, okay? It doesn't always have to do an N, because if you notice the one from the actual paper doesn't have an N. So draw the repeating unit, remove the double bond, straighten it all out and put it in a square bracket. This one then, going backwards on itself, you would re-add the double bond because the monomers are the alkenes that have the double bonds. Looking at the blast furnace then, okay, the blast furnace, 3 raw materials in at the top and then 1 raw material in the bottom because hot air rises. Okay, so iron ore is your source of iron. Limestone removes impurities. Coke acts as fuel. Coke is your source of carbon. Okay, carbon reacts with oxygen in the air to form carbon dioxide. Okay, really nice, easy question. Remember, oxygen is one of the ones that is diatomic. Then it says, give a letter to show reduction. Reduction is the loss of oxygen, the gain of electrons, okay? So we can't see what's going on with electrons here. So we're looking for something that starts on the reactant side with oxygen and ends on the product side without oxygen, okay? And that's nice and easy. You can see iron oxide starts with oxygen, has no oxygen at the end. So A, reason for that is lost oxygen. Then it goes on to say that you should be able to make 0.7 tonnes. You only made 0.65. So what is the percentage yield? That's from last year. So you do actual, what you actually made, over the theoretical. Okay, so actual, what you made over theoretical, times by 100 because it's a percentage. Next question then, looking at the stages of making copper sulfate crystals. Okay, so crystals. State what the pupil will see when all the acids reacted in stage 1. Okay, an excess of copper oxide at the bottom. Also, all acid used up would have been accepted. Name stage 2 is filter. Why do you want to do it? Remove excess copper oxide, so you've got your solution of copper sulfate, which is what you're making. Okay. Complete the word equation. So I would have written out complete the symbol equation. Write out the word equation. Think about it. So you've got copper oxide plus sulfuric acid would make copper sulfate. So if you need to, do top, swap, drop. And it's an oxide, so it'd be plus water. Okay, 2 marks for that. Nice, 2 marks. Hydrochloric acid was used instead of sulfuric acid. Give the name. So it would be copper chloride instead of copper sulfate. And again, it would have been Cu2 plus Cl1 minus. And you could have done Cu2, Cl1. Swap them, Cu1, Cl2. And then drop them is what we got there. Okay. Again, there was 4 nice marks there. Really nice marks. Okay, we've been practicing that. One advantage of recycling plastic bottles, less end up in landfills, okay, and then there was quite a complicated graph here which didn't photocopy very well, but just look for the row it was in. Greatest increase, okay, by there. Then it says, describe how the percentage of recycled changed between 1960 and 2010. Steadily increased between 1980 and 2010. There was a decrease between 1960 and 1940. Okay. Why does recycling have less of an effect? Because so many were sold. Okay. Because there's such a large increase in selling them, even though you're recycling about 20% of them, there's still that 80% that have been sold and haven't been recycled. Okay, calculate the number of plastic bottles not recycled in 2006. 2006, how many were recycled? How many were sold? Take it away from each other. 48 billion. Ionic bonding then. Now look with ionic bonding questions to make sure that you've answered this here. Can you see how there's a question here where there's nothing to write? It says, complete the diagram by adding the charge on the oxide ion and the electron structure of the calcium ion. Okay, so calcium started as 2882. It lost 2, so it's going to end up as 288. Oxygen's gained 2. Remember, it's the wrong way around, to be 2 minus. Give the chemical formula again. Turn to the back of your book. Look at the swap top. Turn to the back of your book and do top, swap, drop. Okay. The next one then says calcium oxide is a giant ionic structure, has a high melting point. So I went and ticked the ones that had high melting points. Then soluble in water. So I ticked the ones that were soluble in water. Conducts electricity when molten. Okay. So you can see here that Y is the only one with 3 ticks. So that's why I decided it was that one. Carbon and hydrogen bonded together would have been that one. Look at how many carbon's got in its outer shell. So carbon's got 4. Hydrogen's got 1, so you can bond it up, okay? Think about that's a covalent bond. That's one that you should know because it's methane. It's one that happens quite a lot. Nice, easy question then that we're all really confident in doing. Reactants, products, okay? First off, calculate all the bonds you need to break in the reactant, so you had 2 hydrogens and 1 oxygen, so you should have had that. Then it said in the products, remember to count them. 1, 2, 3, 4. Cross them off if you need to. Use your answer for part A to calculate the overall energy change. Reactants minus products minus 486. A bit of a tough 6-mark question then, okay? So it's looking at magnesium and copper sulfate, okay? The big thing with this is to know that magnesium is higher up in the reactivity series than copper. So magnesium will displace copper. The blue solution, which has got the copper in it, will turn a rusty colour as the copper and magnesium sulfate form. So you're forming copper on its own and the magnesium sulfate. So you're no longer going to have copper sulfate, which is where the blue comes from. The magnesium ribbon will disappear and copper will form. There will be bubbles and a slight temperature increase. The mass will remain the same as there's a bung on the top. There's a bung to stop gas escaping. And then for an extra mark that I knew they would want, I included the word and symbol equation. Electrolysis, make sure you write panic straight away and oil rig just to help you out so you can work out what's going on. State at which electrode aluminium is formed. Aluminium is positive, so it's going to go towards the negative. So cathode, negative, cathode. Negative is cathode. Write a balanced symbol equation for the overall reaction taking place, okay? This is tough, but it was worth 3 marks, okay? So aluminium oxide is what you start with. You end up with pure aluminium and oxygen, and then you had to balance it, which is mostly the most complicated of it. Explain how extraction of aluminium may contribute to global warming. Requires electricity, which needs fossil fuels to work, so burning CO2. Different property, aluminium, really low density, used in planes. You could have gone with malleable because it can be into cans to recycle. This then, be careful of this because I did this wrong and I've just realised. So the mass of water is not 20, okay? The mass of water is 100, okay? Okay, so it says here the mass of water, which is 100 by there, 4.2, which is a constant value, and then the temperature change for butanol, which is there. Times it all together, and you should have got that value. Okay, nice 2 marks for just inputting into a calculator. Apart from 1 gram of fuel and 100 grams of water, 2 things that should be kept the same. The distance of the spirit burner to the bottom of the beaker, where the thermometer is in the water. Could have done surface area of beaker. Okay, so there's kind of 3 or 4 that you need to learn and have them banked to use, okay? One similarity of these 2 values, so the values on this page and the values on the previous page, or increase as carbon chain increases. Theoretical values are much higher. Big reason for that, and this question does come up quite a lot. Be careful of this if it does come up. Heat loss to surroundings. Experiment needs to be insulated, so you could use silver foil. You could use cotton wool. You could put a lid on it, and you could even do it in a vacuum. Okay, so there's loads of things that you can do there to ensure that it's properly insulated. But for 1 mark, they maybe didn't need that, but just thinking about more marks. Okay, just a note here, everyone gets this table and everyone gets a periodic table, so everyone gets everything they need at the back of the paper.